This nano lecture will briefly describe the pharmacokinetic parameter volume of distribution. Volume of distribution relates the amount of drug in the body to the plasma drug concentration. It is not a real volume, but rather it is a parameter of the drug that is determined experimentally. Because it is not a real anatomical volume, it is sometimes called the apparent volume of distribution. Following a given dose, we can calculate volume of distribution by determining the drug concentration in the blood and then asking the question, in what volume would I need to dissolve the amount of drug I gave to end up with this drug concentration? Quite simply, if we give a patient 100 milligrams of drug intravenously and measured the initial concentration of 100 milligrams per litre, then the volume of distribution for the drug must be 1 litre. We know that highly lipid-soluble molecules are more likely to cross biological membranes. It follows that such molecules are more likely to penetrate tissues, thereby disappearing from the plasma and resulting in a larger apparent volume of distribution. Hydrophilic drugs, and especially large molecules, might be expected to have smaller volumes of distribution, reflecting restriction to the plasma. Another important determinant of volume of distribution is the relative affinity for plasma proteins such as serum albumin compared to that for the tissue compartments. If a drug is highly plasma protein bound, it is likely to have a smaller volume of distribution, again reflecting restriction to plasma volume. The formula here shows the relationship between tissue affinity and affinity for plasma proteins in determining volume of distribution. Volume of distribution is useful for working out a loading dose. Without a loading dose, steady state will be reached more slowly, since the drug must first fill up this volume before steady state concentration, which is determined by clearance and dose rate, is established. Loading dose can be calculated using this simple equation, where loading dose in milligrams is equal to volume of distribution times the target plasma concentration. It might be an idea to revise the previous lecture on clearance to consolidate your understanding of clearance and steady state dosing.